Morning. Let's go to start the lecture today. Is a special lecture suggested by ETLUE, a very good idea to introduce all the Marie Curie COFUND beneficiaries. And I will just make a short introduction about the program. Okay, this is a program called, the title is R2STAIR, Boosting Your Postdoctoral Career in Prehistory at IFES CERCA, and is co-founded principally by European Union and Maria de Maeztu Certification of Excellence program. Okay. To situate yourself in the strategy of IFES, this is a type of program that is situated in the talent attraction and networking. So this is a very good opportunity for all IFES researchers to take profit from these hired researchers to expand the networking and to reinforce the capacity of IFES to get grants from other programs. Okay. So here in this program, IFES becomes an agency. Okay. That is a program of 2 calls to hire 8 R2 researchers and their projects in 2 calls, 2 per 4 researchers. This is a selection process, has been a selection process in these 2 calls, okay, that they have followed, coordinated by an academic committee composed by Carlos Sala, Carlos Lorenzo, ETLUE, Pedro Rodríguez, Ignacio Pastor, Marta Fontanals, and Laura Pérez, and as managed by me. This program wants to, the researchers can benefit from this life cycle that IFES has in the research in prehistory and human evolution. Okay, that's the philosophy of the program. Involve the researchers in this philosophy, and there is a coordination team, a support team to all the researchers with different profiles, from the career development officer, the data officer, outreach manager, communication manager, knowledge transfer manager, etc. To help the researchers to execute their research, but specifically the training program, career development program, and data management plan also. Okay, that's the big target, and to get to help the researchers to be involved in other type of activities, such as outreach and transfer knowledge activities. The program is co-funded by the European Union, the Research Executive Agency, and also by IFES. Okay, this is the total budget. IFES will have to co-fund this program from certification Maria de Maeztu, ICERCA agreement, and the research groups from AGAU. Each researcher has a project with a specific budget for living and mobility allowance, mainly the salary, the research training and networking. This is the budget specific for the research, training and networking, and a specific one for the secondment between 2 and 4 months. Okay, which are the researchers hired today that today are going to present their projects. You can see here the candidates, the area of research, the project title, the supervisors, and the execution period. And that's all. This is my introduction, and now we'll begin with all the lectures. Okay.
Okay, perfect. So hello everybody, I'm Loïc Lebreton. I'm doing a project on the impact of climate variation during the last interglacial in Western Europe using small vertebrates, and I'm supervised by Dr. Juan Manuel Lopez Garcia. Yes. So during my PhD, I study small mammal, birds, and lagomorph to develop a multi-taxa method. And I mostly, okay, there is no images. Can I charge my presentation?
Yes.
Because I don't see the picture of the presentation.
Okay. Now?
Okay. Okay. Do you see it? Do you see the presentation?
Now? Is it okay for you now?
Yeah, yes, it's okay for me.
Okay.
And for you?
Yes, yes, perfect.
Okay.
Perfect.
Okay.
Go on,
So
go on.
I did my PhD in Perpignan, and after I moved to Paris in HNHP, and I was doing several expertise contracts that allowed me to devise the site I studied. And since last year, I'm doing a postdoc here. So can we pass? Okay. My research topic are mostly on two axes: paleoenvironment, mostly on climatic transition. Also, I studied climatic refuge during cold and warm phases. On taphonomy, I'm studying the modality of deposition, how the small vertebrate was accumulating in the site. I'm also trying to study the timing of human occupation using the density of small vertebrates. And quite a long time ago, I studied small game exploitation. Notably here, you have cut marks on beaver remain. So this project is focusing the climatic deterioration that took place after the Eemian, which is the last interglacial, around 100 kilo years. And this climatic deterioration will had impacted Neanderthal population, their resources, and the environment. So these climatic changes, the climatic changes are well known on the continental scale, with pollen mostly. And our question was how this impact of this environmental change were on a local scale, and this is why we use small vertebrates, because they are very useful to have local information. So for the paleoecology, we were to the multi-taxon approach with bird, lagomorph, insectivore, and rodents. And the taphony part, we are looking if there is some bias linked to the modality of deposition, and if there is some also some human exploitation of small game. So our sites are 5 French sites in northern France, with Caour, Oisier, and Resson, who are quite sure of the Eemian datation, and the Roselle and Sick who are MES5, but quite less recent than the Eemian. And we compare it with sites from Spain, like Valdavara 3 and Cova del Rinoceront, and Italian site also, Grotta Maggiore di San Bernardino. The methodology, so for the identification, is quite the normal part. For the taphonomic analysis, we are looking for the faunal spectrum, the skeletal representation, and the surfaces modification. But the big part is the paleoenvironmental reconstitution. We will try to develop a new methodology to apply the mutual eco-geographic range method on rodent. For this, we use QGIS tool, and this is why I'm here in Valencia to do my secondment. And also, we will use also the more classical method like bioclimatic model and quantify ecology for the climatic parameter, like the mean temperature, the summer-winter gap and the mean precipitation. And also we're looking at the paleo landscape with M-beta index and the climatogram. All this kind of analysis, we can integrate this local data into a more regional and after a more continental data for this climatic variation, and this will allow to have a better understanding of how Neanderthal responds to climatic variation in the north of Europe, and also to compare it with the south, where we have more information. Thank you for your attention.
Thank you.
Okay, so good morning to everyone. I'm Iván Rey-Rodríguez, and I would like to present you my proposal for the Marie Curie COFUND. The title of my project is Palaeoecological Reconstruction based on new methodology for taxonomic and taphonomic rodent studies. And it belongs to the Palaeoecology research area. And now I'm working with Beatriz Gamarra and with Yolanda Fernández-Jalvo. So first of all, I would like to introduce myself. I did my master in quaternary archaeology and human evolution at Universitat Rovira i Virgili in Tarragona. And after that, I got an Erasmus Mundus scholarship in order to do my PhD in the Natural History Museum of Paris with a research stay at Università Ferrara in Italy. I finished my PhD on 2021, and at the end of that year, I got a Margarita Salas research fellowship at Università Rovira i Virgili in Tarragona with a research stay at Tübingen University. Recently, in October, I started with my Marie Curie COFUND, and I will be here, well, actually, yeah, at IPES for 2 years. So my project is focused on Western Asia. That is an important place because it's a crossroad between Africa, Asia, and Europe, and it's a very attractive area for humans, evidenced by the high number of sites, such as the Manisinas and Ramla, and so on. The project will be based on the application of small vertebrates as a useful tool for the paleoenvironmental and paleoclimatic reconstruction. Among the different rodents, I select Meriones because, as you can see here, they have a distribution for North Africa and Western Asia, and it's really important to understand the current distribution, but even the past one, in order to see if this one has changed or not. Also, the main problem with Meriones is that the identification of fossil material is not elaborated satisfactorily, and it's something that we are trying to work on that. Meriones have different types of habitats, such as the ones that you have here, such as desert, grasslands, and so on. So the correct identification will improve also the paleoenvironmental and the paleoclimatic reconstructions. So this project attempts to answer the following question in order to obtain several objectives. So the first question is related with the roots morphology and also with the application of the ADJ that I will explain you later what it is, and the taphonomical and taxonomical identification. With this, I would like to evaluate the role of the ADJ and the root traits as a taxonomic proxy. The second research question is related with the origin of the accumulation and the 3D geometric morphometric analysis, and to see if it would be possible to include the teeth that has been digested. In this case, we include a light and a moderate digestion. Our objective with this is to evaluate the taphonomic effect of digestion processes and also to quantify the loss of the enamel and the dentine. The third question is related with the genus Meriones and if there are any internal differences between the different Meriones species. And with this, we would like to contribute to the knowledge of Meriones and try to differentiate between the species. The last question is related if we can quantify the climatic fluctuation related with the different human dispersions. In this case, we will try to do it with the material from the Manisi for the first human dispersion, and then with the arrival of anatomical body human at the end of the Middle Pleistocene with the material from Islia. With this, our objective is to provide new data on the paleoecological reconstructions in this area. The methodology that I will use, first, I have to scan the rodent teeth, and then I will obtain a 2D view. And it's really important to remind that this is a non-destructive method. When we have these scans, we will try to divide or to separate the enamel and the dentine, and try to work with the ADJ, that is the enamel-dentine junction, that is the union between these two parts. Here you have an example with a rodent. In purple, you have the dentine, and in green, you have the enamel. So the part that we are interested in it is that is between these two parts. So when we have our model, we will try to work with the 3D geometric morphometric, and we will place the points, the landmarks and semi-landmarks. This proxy has been used in hominins, however, it has never been used on rodent studies. And then we will try to plot the result. The impact of this research is that first, it would be a unique opportunity for me in order to integrate different approaches that have been used in anthropology, archaeology, and paleontology. With this, I will try to contribute with different, first, try to currently identify the rodent species, and in particular with meriones, providing new methodology and new morphological data on the teeth, and trying to be an alternative to traditional genetic and morphological studies. Then I would like to also contribute the taphonomic studies with an innovative methodology and high resolution results that will allow us to see the internal structure of the different teeth or bones or what we are using on it. Then I would like to continue or establish a new research line at IPES that will be based in the virtual paleontology, providing open access data that will stimulate the networking with other institutions, such as museums, university, or even cultural entities. So especially it will have an impact on my research career because with the application of these innovative and accurate methodologies in the paleontology, hopefully it will increase my scientific visibility. So thank you very much for your attention. And if you have any questions.
So good morning, everyone. I'm Claudia Speciale. I am an archaeobotanist, and my main research topics are the archaeobotany of the small islands and the neolithization process in the central Mediterranean. So before coming here, I was a researcher in Sweden, in Göteborg University. I was working on a big project about collecting archaeobotanical data from all over Europe. I work mostly on recent prehistory, as you can understand. So I was working mostly on neolithization of Europe and the archaeobotanical data. Before that, I was postdoc fellow in Italy for a project about small islands in the southern Tyrrhenian. And my PhD thesis was also on small islands. So basically, I've been working on small islands for a few years now. Here, I'll be developing a project with my supervisor at LUE from the group of archaeobotany. The project is called SILVA. This is the acronym. It's Sicilian Small Volcanic Islands Vegetation After Human Arrival. So basically, I will see how vegetation changed after humans arrived, mostly during the Neolithic. Maybe we're going to find something older, we still don't know, but as much as we know now, Aeolian Islands, Ustica, Pantelleria, and Pelagia Islands were all colonized during the 6th millennium, 5th millennium BC. The islands are very different. I mean, they're all volcanic and they're considered small, but they range from 5-6 square kilometers to around 70-80 square kilometers. So they are very different also in terms of ecology. So I will try and compare if I can find the same species all over the islands. And also the case studies are very different because some of them have been already studied. So there are some investigations going on. Some of them will be totally new for the project. So here you can see the main objectives of the project. Basically, I will try to understand the impact of the first humans in the landscape, doing also new field research and new test pits, and trying to cover that with the C14 dates. And then I will spend my time in the lab characterizing the plant assemblages. I work on macro remains, so I work both on wood charcoals and seeds, but I would say that most of the assemblages will be made by wood charcoals. And after this, I will spend some time trying to reconstruct the change in rainfall regime and doing some analysis on the carbon-13. So this is more or less the workflow. As you can see, I'm here now because I'm doing my laboratory parts, but I've already been on the fieldwork, and I will go back on the fieldwork very soon. The ideal would be to have at least 3 or 4 new test pits in different islands, but I'm also following some investigations that are ongoing from other research centers. For example, in Pantelleria Island, we can have more sites from different chronologies. And after all of this, so in around 1 year, I will go to Lleida and Montpellier. That is where I have my short visit and secondment. And I will select some of the samples to perform the analysis on the carbon-13. And then after all that, at the end of this secondment, I will come back and elaborate the final data and do a final workshop. The impact part about my career, of course, what I will do during these 2 years is to learn new techniques that I don't know about, especially about anthropology, but also, of course, the data 13, C14, 13 analysis and statistics with R, and more in general, some impact with open and public science. I will prepare grants and application, of course, for what happens after and increase the number of my scientific publications. What I really hope at the end of the project is that scientific community can use this data set, because unfortunately so far the archaeobotanical analyses are not very common in Sicily. So my main aim is not developing new methodologies, but instead providing new data that we are missing. And then, of course, create a data set for Delta 13. I mean, it's still a methodology that is not always shared by all the scholars that work on isotopes. So trying to understand if it works, if you can really use and adapt this methodology to the islands, and more in general in the use for plant remains would be also one of the objectives. And then, of course, try and create a reference for all the people that are working on small islands, because we are going to provide also more in general new data on the islands and on the pattern of the demographic pattern of this area around the city. And the final impact, of course, is for local communities and wide public. So we really hope that the analysis of the change in island vegetation can be a tool used to manage the contemporary environments and reconstruct the regional ecological framework. And finally, try to communicate, this is one of the part of my communication plan, to communicate how the daily life of a researcher is. Some of you already know me because, as you see from the map, I've been around the Iberian Peninsula almost all of the time since I started doing research, and since we started talking about the networking. So this is my network in the Iberian Peninsula. And a little bit about me, some of you already know. I started studying at the University of Porto, where I come from. I did my master's degree there, and then after that, I got a PhD grant to work with the assemblages from Pinilla del Valle in the center in Madrid. But it was a grant from the Portuguese Science Foundation, the government agency that attributes these PhD grants. But it allowed me to spend 2 years in Alcalá at the museum, studying the assemblages from this site. After completing my PhD during the pandemic, online and in isolation, I went back to Portugal, of course. And because we were at home without any prospects about what the future would be, I decided to enroll again at the University of Porto in connection with the University of Coimbra, doing post-graduation or a master's in geology to increase my skills while I was applying for postdoc. And this time I got a small grant to work in a project in the Coa Valley, again, to study lithic assemblages. What are these lithic assemblages in common is that most of the collections that I studied are composed of quartz or quartzite, usually the kind of raw material that people don't want to study. And they don't want to study it because, of course, they don't have the same characteristics that allow us to sometimes pinpoint into a given outcrop and give us mobility data. But I will talk a little bit further about it. And then I got a postdoc. I moved again to Spain. I spent a year at CNIE, again, working in the south of Spain in an Acheulean-based assemblage, most 99.9% of quartzite. which allowed me to improve and also apply the skills that I got during that master in Portugal into that quartzite assemblage. So this time, those 3 sites that I talked about, I saw that there's this love triangle, or the Bermuda triangle, if you want to, it depends on the perspective, that seem like so far away from each other, and what they have in common. But what they have in common is that, first of all, the way that people usually perceive these assemblages. So most of these, so going back a little bit. So most of the times what happens, and for the people working in lithics, but this is mostly for the ones who do not are in the lithic. We usually, what happens is that chert is given a priority in the study of lithic raw materials, and other raw materials, such as can be quartz, quartzite, other sandstones, or rhyolite, any basalt, they tend to not be studied with the same degree of detail, because they are interpreted as being from an archaic or a less quality raw material, or a more archaic expedient exploitation. And so this is a bit outdated. These ideas are changing, but it's still a process. There's this idea that with time, there is an increase of the use of better quality raw materials, that meaning flint or silex or chert, as you want to call it. But still, there are, in this triangle, most of the assemblages are still throughout time, because here you have examples from lower Paleolithic until upper Paleolithic, where there's a big quantity of quartzes and quartzite being exploited. And this is because these are the most common raw materials in this area, which they have in common, all of them, is that they are located in the central Iberian zone, where outcrops of quartz and quartzite are very common. All these sites are also located in valleys where these raw materials are transported naturally. So this gave me an idea to develop a project from here on. So is this happening in other sites or in other regions where these characteristics also can be applied in some way or not? Or how can we study these raw materials, and how can we distinguish them, or if not, and can we see this change through time or not? So in this context, I got the opportunity to study here as this postdoc, the assemblages from the Payre and Abri in France, which is also 2 sites are located in a valley where these raw materials are also common, but exploited in less quantity, which is interesting that even though in areas where chert assemblages are composed mostly of chert, the degree or the percentages of local and non-local raw materials tend to be more or less the same, which is between 80 to 20%. So there's this ratio that seems to be common independently of the kind of raw materials that they're being exploited. And of course, the chert assemblages have been studied, but the rest has not. And my project will be to study the other raw materials from these 2 sites and see if we can see any pattern that we can then compare to what is happening in the Iberian Peninsula, and understand behavior of Neanderthals in what concerns the raw material procurement strategies. And talking about quartzite, because I said at the beginning of the presentation that quartzite tends to not be studied because if we look at it macroscopically, most of the time they look all the same and very similar, so we won't be able to distinguish or pinpoint different locations because their internal differences are very small. But once you start to cut them, you see that they are not so similar. So you can see differences from a macroscopic point of view. And then if you go into the microscopy of it and the geochemistry of it, there can also be small differences. So taking that experience into account, and this project and the sites in France that I've mentioned, we'll start, of course, through a microscopic evaluation to see what kind of raw materials do we have and can we distinguish in these assemblages, and then to go and map the region to see what raw materials are available in the region and what are being exploited, and the ones that are not being exploited, it might be there, and why are they not being exploited in the same way.
And then there's going to be all the analysis starting from, of course, the microscopic as well, petrography, which is very important, and then some geochemistry and the statistical comparison of all these data. Lastly, the one skill that I intend to develop here at IPES mostly is about the GIS modeling and the mobility aspect of the project. So what is the impact of this project? And this is, I'm almost finishing. I think I'm way above the 5 minutes. We want to add into this still very small corpus of data of non-plated raw materials to understand what are the exploitation strategies at a local scale. Because and when I say we, I say research in general has been trying to look for long distance movements, but what is happening at a local scale? What are the characteristics that an area or a region has to have for it to attract Neanderthals in terms of raw material availability? And lastly, build this theoretical approach of Neanderthal behavior factors. As my colleagues have said before, we have divided this impact of objectives into local, regional, and interregional. This is more or less what I've been just said. But of course, we'll start at the local scale, and we'll grow into understand at the regional level what this means in this region of the Rhone Valley. Because as we've seen in the map before, I don't know if you remember, there's a lot of other Neanderthal occupation sites in the region, so then we can compare regionally, but then we can also extrapolate and compare to what we've seen in other regions, such as the Iberian Peninsula, which is closer to my research. And that's it.
Hi, hello everybody. I'll take the opportunity to thank IPES for having me on board. I'm very excited to be here, but above all, I'm super excited to be able to work with one of my heroes, Ruth Blasco. Thank you. So yeah, I'll be quick. I'm Mariana Nabais. I'm an archaeologist that likes to dig in Paleolithic caves, like a lot of people here. But I did a lot of work in commercial units as an archaeologist and as a zooarchaeologist as well. I was a teaching assistant in zooarchaeology and in field methods in archaeology in UCL. I was also the assistant director of their field work. And then in 2018, I started my own field school in Portugal, where we have a very strong policy in terms of outreach and teaching the students how to dig. Well, it's a field school. And engaging with the local community as well. I finished my PhD in June 2021 in UCL. And then I moved on doing a postdoc at the University of Lisbon. In the meantime, I had 2 children, so if we're working together at some point, they will probably show up on site. I really like napping, so I can always be ready for a drink. Okay, now, talking about Neanderthals, there is still this idea of Neanderthals. Most of you know that they were kind of like monkey, ape-like brutes. And of course, they weren't able to adapt to different circumstances, so that's why they got extinct. But we know that they interbred. So in 1998 in Portugal, it was the first hybrid Neanderthal and Sapiens child found. And then in 2010 and onwards, Savanta Pabo and his team started developing all the genome sequence. So since then, there has been loads of evidence that Neanderthals are not as dumb as we thought. You know, it is possible that they made cave art, personal ornamentation, they made fire. So we're kind of changing the idea of Neanderthals. This is also clear within the zooarch assemblages. The traditional ideas say that Neanderthals avoid the coast, that they didn't eat marine resources at all, or tortoises or birds. They were really focusing on eating mammoths and rhinos. Well, it is true that they were eating large game, but it's also true that they were, exploiting smaller resources like rabbits and tortoises and birds and limpets and crabs. And sometimes they were even over-exploiting them, such as tortoises. We have evidence in changes in size that shows intensification. Soon it will be published a paper showing that the same was happening with limpets. So Neanderthals were clearly able to adapt to different environments and different climates. So my project specifically will be focused in Portugal. I'm going to be studying assemblages coming from sites dated from the Middle and the Upper Paleolithic in Portugal. I'll be mostly looking at small prey and following, the standard procedures in zooarchaeology. So I'll be looking at the collections, building my database, then recording everything related with measurements and bone surface taphonomy or shell surface taphonomy as well. So we can produce these skeletal part diagrams, do all the body change analysis. And the idea is to explore and challenge the validity of these traditional subsistence models in which Neanderthals are seen as just targeting a very limited amount of resources, and to try and design a new evidence-based model in which ecological adaptability and resource use can be compared and contrasted over time. So to give a focus for my research, the first thing is to try and understand who are the agents of the bone or shell accumulation and what were the strategies used by these early humans throughout the Middle and the Upper Paleolithic, and what factors led to changes in the human paleo diet. And finally, what were the strategies used when exploring the territory and when responding to changes in the environment. So my line of research has been to kind of show that Neanderthals and Sapiens, they actually, even though if you look at them anatomically, they're a bit different, but in terms of behavior, they are pretty similar. We have, well, at least Western countries have still some genome within us, Neanderthal genome. So at what point can we discuss the term extinction, Neanderthal extinction? Well, we'll have a debate later over a beer. And in terms of impact, what I noticed recently, quite unexpectedly, is that it's not just the academic community that is worried about these topics. We are the offspring of Neanderthals. And I had the most crazy experience recently with Neanderthals eating crabs and like the general public going mental about this. So what we do does matter. And I'm very happy to be here. So thank you.
My name is Federica Landi. I just started here as a co-fund researcher. I'm Italian, so my bachelor and my master were in Rome. And as you can probably tell, the Italians are planning to colonize the Ibis permanently. So we have a big community here. So I was looking here at primate locomotion and adaptations in the cranial base to primate locomotion, and different strategies of foramen magnum position and morphology of the cranial base in different types of primates. I moved on to a different subject when I moved to the UK. So I explored sort of all corners of England. And my PhD was about cranial growth and development in modern humans compared to Neanderthals. And so we do this using a technique called geometric morphometric, which compares size and shape between different specimens, basically. So after the PhD, I did quite a bit of teaching, first in Plymouth and then in London. So because of the expertise that we can develop when we apply geometric morphometric, which are expertise about learning about, in very detail, about the anatomy and the morphology and the muscles and all the organs of the species that we study, I was able to sort of transfer that knowledge and teach into medical schools. So I was in charge of teaching musculoskeletal anatomy to medical students because of the sort of flexibility that they have in England. Although you're not a doctor, medical doctor, you can teach in anatomy schools. However, after London, I decided it was very rainy and the food was terrible. So I decided to move to sunny Spain, where I'm currently doing a project that is a continuation of the PhD project about cranial growth and development, comparing modern humans and Neanderthals. So in general, my expertise, as I said, are geometric morphometric, virtual imaging, musculoskeletal anatomy, and a little bit about analysis in RStudio. So with geometric morphometrics, you can do a lot because it allows you, when you place those landmarks that you see here, which are homologous anatomical points that you can place consistently in different specimens, this allow you to compare, for example, different species or different populations in terms of what we call form, which is shape and size. And so what I'm doing with the current project is to do so by comparing how we grow and develop and putting it in analysis and in comparison with how Neanderthals grow and develop in terms of bones first, but also in terms, for what the little we can tell, in terms of muscles and organs, by using some sort of translation methods in which I know about the muscles in modern humans, and I try to translate those data into what the muscles of Neanderthals could have been in relation to how heavily built was their cranium, basically. Anyway, so but the publications are a bit diverse because I've looked into, as I said, primary locomotion, growth and development, but also I've looked into the face and the development of the face in modern humans. And this is of interest also of clinicians and surgeons, for example. So one of the objectives of the project, which is called, a very long title, I call it ONSET, which is Ontogenetic Neanderthal and Sapiens Trajectory. One of the first objectives is to build kind of a normal growth and development model for modern humans by looking at these 3D models that are derived from CT scans in terms of bones, muscles, and organs of the head. And this is a reference that is important, as I said, for clinicians and surgeons to plan any sort of facial reconstruction, for example. But also, of course, it's of interest to anthropologists who are looking to compare, for example, the morphology of different populations or the ontogeny of different modern populations, and also to compare modern humans with other fossil hominins. So we need a reference model to then be able to go and explore the variety and diversity of the different kind of types of growth and development. And so the second step will then be to sort of apply this model that I created with modern humans to Neanderthals, to kind of explore if the two so different adult morphology derive from parallel kind of trajectories, ontogenetic trajectories, or if they differ slowly during their growth and development until they reach two very different adult morphology. So as I said, the kind of general aims are to investigate the mechanisms of pattern in craniofacial ontogeny and to answer the big question, which is, do these two species really develop in a significantly different way? Because we still don't know, and there are papers that suggest they don't, and I strongly believe that they do. Actually, they grow very differently and they reach different morphology following different patterns of integration and covariation between their regions. So yes, so to recap, as I said, the objective again is to create this much needed ontogenetic 3D reference of modern humans. You have an example here of a Sapiens neonate specimen, and then to build a Neanderthal model. Of course, the second step is like much more difficult because we have 12 specimens or 15 if we are lucky. So the ontogenetic trajectory of Neanderthals is quite hard to build. And also, as you can see, the fragmented nature of the fossils it makes the process even more difficult, because to reconstruct, you need to sort of warp the infants into modern human infants into the infant Neanderthals, and then so on. So to do so, I'm going to go to London and to Pisa in Italy to ask for help with Carlos Lorenzo first, also to sort of learn faster and better ways to reconstruct the fossils to then compare the species. That's it. Thank you.
Hello, everyone. My name is Weiya. The project I'm conducting at IPAS is entitled Origins of the Earliest Farmers in Central China, a Lithic Perspective. I wrote this proposal with my supervisor here, Deborah, and I also will work with people in the Lithic lab, like Andrew Ole and other people. Yeah. So something about my education and research background. I got my bachelor and master degree in China. I majored in applied chemistry and archaeological science for my master. Then I continued with my PhD at Leiden University in the Netherlands. During that period, I traveled to different European countries, USA, Ethiopia for conferences and fieldworks. And after I finished my PhD, I did a 2-year postdoc in China, and I started my contract here in IPAS in December last year. My research interest is centered around material culture and food waste in early farming societies. I often study these topics through the residue and use-wear analysis on stone tools and pottery. So talking about farming, Neolithic China was one of the oldest primary centers of independent agricultural development. For example, northern China was the place where millet agriculture started, and rice cultivation began in southern China in the Yangtze River 10,000 years ago. So, but our project will focus on central China, where the excavation at the Neolithic site of Jiahu provided rice remains dated back to 7,000 BC. So the Jiahu people thus were recognized as the earliest farmers, rice farmers beyond the Yangtze River. As you can see from these pictures, the site has amazing material culture. The Jiahu people made big size grinding stone tools, playable bone flutes, and thousands of turquoise ornaments. And however, we don't know where this population came from. One of the hypotheses is that they probably migrated from southern China because of climate change and the sea level rise. So they had to move to somewhere with higher like altitude. And that also explains probably from southern China, migrated from southern China. And that also explains why this population first practiced the rice agriculture at the beginning. It is a very interesting proposition, and we would like to testify in a lithic perspective. The idea is to compare the lithic assemblage at Jiahu and other earlier sites and see if it's possible to find the potential correlations. For the current project, we will focus on chipped stone tools from the site of Jiahu and study their typology, technology, and functionality. For the functionality, I will use the methods including use-wear and residue analysis. The results of our project hopefully will put more insights into the mobility pattern, subsistence strategies, and crop production in one of the earliest farming societies. And for myself, and to be here at IPAS and working with many lithic specialists is great, because I learn new skills like every day. And through this project, we also hope to bring together people normally only working in Paleolithic or Neolithic periods, because in China, like the chipped stone tools from Neolithic sites were normally just overlooked. And I also know several people here already started, had projects working with Chinese colleagues before. So through this project, we want to further enhance maybe the collaboration between scholars in these two countries, and may create larger projects together and provide potential positions for people who are interested in this field. I'm sorry I didn't prepare very well, but thank you very much for your attention.
Well, hello to everyone. So it was a session very complicated. Now I'm Andrés Robledo. I come from Argentina, Córdoba. I attend to the National University of Córdoba in the field of anthropology. I made my the master, that is great, and my PhD and a postdoc. So this is like my first networking activity over the sea in Europe. So I'm starting to learn a lot of new things. I work with my supervisor here at Abri, and we started planning a project that involved not only my formation as archaeobotanist, specialized archaeobotanist in field management, but also a project that could collaborate with ongoing projects here at INTERWEAVE. So we call it flying but fuel emission to study light, air, heat, and air quality in prehistoric dwelling from here in Spain. Mainly what we know is that fire was always a central activity for human occupation. It was on daily purpose. It was for extending the hours during the day, for early nights. It was also one of the primarily benefits, the acquisition of light and the warmth in this situation, and it could also involve the different dwelling scenarios that we still don't know a lot about. There are a lot of studies about fuel management and how anthropology could make the contribution into fire situation and food process and material process, but not about how the dwelling in this situation was for the people that live those places. So this project will be located in 3 different types of scenarios: open air, enclosed scenarios such as rock shelters, caves, or huts, and also enclosed scenarios like housing in saturated spaces. Mainly what we're going to do is to study the well-being in this population, considering about the air quality scenarios, the lighting and the warming of these places, and also to contribute to the study of food management by the prehistoric communities, comparing the experiments, the result of the experiments with the anthropological knowledge that we have. For the experimental program, we are going to develop the different protocols. They're going to involve different scenarios about the fuel use. We're going to select the good species that will be part of the anthropological records from 3 main cases: Abri, Monirelsat, and El Mirador, that most of you may know. But the particular innovative in this way is that during the experiment, the fire experiment, we're going to be measuring air quality in the terms of an air monitor of air pollution that will measure fine particles that could be harmful for humans when we breathe. We know that for modern cases, fine particles are the ones most dangerous that could develop cancer, for example, mostly in women and younger children during these scenarios of using fire in closed places. But for the past, we still don't know a lot about this information. There is still a lot of research going on there. We're going to make a contribution also in this relative heat measurement, in terms that we know that with fire you can warm yourself and burn things, but we still don't know how was this fire managed to get this kind of comfort zone. Yeah? And what about light? Because it is one of the immediate results by using fires, but we still don't know much about if this was an intentional purpose when you do the fire or not. Also, during post experiments, I will be doing anthropological study with Etelaloe and doing phytolith analysis and microecological studies with Lisa Schilter in Newcastle as a second. Finally, I believe that this project, which was very synthesized here, but is going to contribute to a lot of INTERCERCA ongoing projects, going to make available a lot of information for experimental data that you will be able to use. And also, as part of COFUND's managed is to work with the open data and start to share this information with other colleagues so they can use it for the investigation, the research. I believe that it's going to be also a new opportunity to start developing a more open way to share experimental data, not only for this experiment, but also if I'm going to be able to use it in another archaeological sites in the future or in another places. And also communication and outreach activities, because it's one of the most important things that we are doing. And thank you for your attention.